Hello everyone and welcome to another Belly Issues video. I am Luke and I am completely fine. There is nothing to worry about. Today I'll be speaking about similarity. I will go through some examples, some proofs, what similarity actually is in terms of similar figures, and I hope you enjoy the video. Leave a like and subscribe, and don't send help because I'm fine.
Okay, so after a lovely talk with Jeremy, my great friend and very good business partner, he's decided that I can finish the last maths video that I will be filming, as long as I reassure everyone that I'm definitely not in any danger and that I'm here definitely on my own free will. And yeah, he's just helping me make these videos. Yep, so anyway, I'll get into similarity. So I'll be talking about similar figures, scale factors, and then the proofs in similarity. So to start, there are 4 minimum requirements of information that you need to prove that a triangle is similar to another. And you can have any one of these to prove that. So firstly, that all the angles in the triangle are equal. Secondly, that 3 matching sides are in proportion to each other. Thirdly, that 2 pairs of matching sides are in proportion and the angle between them is equal. And finally, in 2 right-angled triangles, the hypotenuse and one side is in proportion. So firstly, let's look at scale factor. So scale factor is quite simple. All you need to do is look at the original triangle and the new triangle, and the scale factor is equal to the new side over the original side. So in the example on the screen, we have 24 on the new side and 8 on the original side. So it's 24 over 8, which we can simplify to 3. So that's pretty simple, and it doesn't really get too much harder, except maybe some of the simplifiers are a bit hard, or the next part makes it a little bit harder, which is matching sides in similar triangles. So this is when the triangles are still similar, but they're like flipped around the other way, mirrored, reversed, or something, which makes it a little bit harder to match one side to the other. So to do this, you just want to look for certain things that make it easier to identify which side is which. So firstly, you could just try and mentally flip the triangle around, or if it's a right angle triangle, you could look to match up the right angles and mentally, yeah, it's all about just mentally imaging what you're trying to find and match up those sides. It's not too hard, but sometimes if there's a lot of measurements and stuff like that, it can get a bit tricky. The final part in similar figures is about finding sides in similar figures. So it's pretty much like equations. So in the example on the screen, on the left triangle, the smaller one, there is a side which is labeled x. So once we've flipped it around and got the right scale factor, it becomes x over 12 equals 12 over 15. But then we want to find what x is, because we want to find that missing side. So then we go through just the normal process of an equation. So times the 12 over 15 by 12. And then that leads you to getting x equals 12 over 15 times 12, and then x equals 9.6 once that is simplified. The way that this can get harder is if you have one of the shapes inside of another one. And like you can see on screen, and all you do there is make sure that you're adding for example, the 6 and the 4 to get 10 on the larger side. And that's really all you need to know about finding sides in similar triangles. The next part is proofs in similarity. So as I talked about before, there's the 4 different proofs, which are equiangular, which is when all the angles are equal. Then there's 2 corresponding sides and the same ratio, and the included angle is equal. Thirdly, all the corresponding sides in this are the same ratio. And fourthly, in a right angle triangle, the hypotenuse and one side is in proportion. So I'll show one example because I don't want this to be too big of a video. So we've got these 2 triangles, as you can see on the screen. So firstly, you write an introduction line. So that is in triangle ABC and triangle DEF. So you're clearly stating which triangles you're going to be comparing. And yeah, just sort of an introduction. Next, you want to label reason 1, which in this example is that angle BAC is equal to angle EDF, and then give a reason for that. So that is because the 70-degree angle there is given in the diagram. Then your next line, reason 2, is angle ABC is equal to angle DEF, and again that's because that's 65 degrees, and we know that because it's given. because we've proved that two angles in the triangle are the same, which means that the third angle has to be the same. We can write our conclusion, which is therefore, so the three dots, a triangle ABC, and then the similar is similar to single, so it's like three dashes next to each other. So triangle ABC is similar to angle DEF, and then write the reason next to it, so equiangular. Alright, that's all I've got for similarity. It might not be the most clear video because I've been filming for a few hours now, and with all the harassment from Jeremy, help from Jeremy, yeah, it's all getting a lot of information I'm taking in. So yeah, again, like all the other videos, I recommend you doing your own study. I may have gotten something wrong or just forgotten about saying something. So yeah, make sure you're doing your own work. And again, that's the best way to get better at this sort of stuff, just by practicing it over and over. Hopefully you've enjoyed the video. Give it a like, subscribe, and just watch all the other maths videos or any ones you need to know before any maths exam. And yeah, thank you for watching.